We will try to solve some problems based on refractive index profile and numerical aperture of an optical fiber. We have an optical fiber of a graded index type of a truncated parabolic refractive index profile. As you can see that this is a truncated parabolic refractive index profile. The radius of the core is R, and N1 is the actually the refractive index of the core, and N2 is a refractive index of the cladding, and refractive index varies parabolically as a truncated parabolic curve from the axis of the core to the edge of the core or the towards the cladding. So the expression for truncated parabolic refractive index profile, that is the equation for the truncated parabola is n of r is equal to a plus b r squared, where the radius is between 0 and maximum. This is the radius of the core, 0 less than r, less than or is equal to r. So r is variable. This means that when r is equal to 0, that is along the axis of the core, n of r is equal to n1, then it varies gradually, that is according to a parabolic profile, and when you reach the edge of the core, that is at the periphery of the cladding, that is when r is equal to r, r is the radius of the core, n of r becomes n2. So between the axis of the core and the edge of the core, the refractive index varies as a parabolic profile, that is a truncated parabola. So we will try to arrive at an expression for refractive index profile n of r, to obtain an expression for refractive index profile n of r. We have the expression for truncated parabola n of r is equal to a plus br squared for 0 less than small r less than capital R. So when r is equal to 0, n of r is equal to n1, and when r is equal to r, n of r is equal to n2. So we can see that n1 will be equal to a from the expression. A is actually n1, and we can find b by simple rearrangement, that is and substitution. N2 is actually a plus b r squared, and we can find that b is equal to n1 minus n2 by r squared. So substitute n1 equal to n1 here. So we can find that b is equal to minus of n1 minus n2 by r squared. So the relative refractive index difference delta is given by n1 minus n2 by n1. So now you have to substitute this into the expression for n of r, that is a plus br squared. Now that n of r is equal to a plus br squared, where a is equal to n1 and b is equal to minus of n1 minus n2 by r squared, we can see that n of r is equal to n1 minus n2 by r squared into r squared by substitution of a and b into the expression for n of r. And by solving, we can see that n of r is equal to n1 into 1 minus n1 minus n2 by n1 into r by r the whole squared, where n1 minus n2 by n1 is equal to delta, the relative refractive index difference. And this happens for small r, that is a radius less than the capital R, the radius of the core. So now refractive index profile is given by the expression of r is equal to n1 into 1 minus delta r by r the whole squared for 0 less than small r less than capital R, where r is a maximum radius of the core, and it will be equal to n2 for r greater than capital R, that is towards the cladding. So the refractive index of the core varies as a truncated parabola according to the expression n1 in 1 minus delta r by r the whole squared, where delta is equal to n1 minus n2 by n1.
You are given n1 is equal to 1.465, n2 is equal to 1.45. Apply the formula. N is equal to square root of n1 squared minus n2 squared is equal to square root of 1.465 squared minus 1.45 squared is equal to 0.2091. We have yet another problem. The refractive index of the core of a fiber is 1.48 and that of the cladding is 1.475, and the light enters the fiber from a medium of refractive index 1.4. You are asked to find the acceptance angle. So you are given n1 is equal to 1.48, n2 is equal to 1.475, and n0 is equal to 1.4. Numerical aperture is given by the expression square root of n1 squared minus n2 squared is equal to n0 sin phi, and you substitute for n1 and n2, you will get a 0.1219, and phi is given by sine inverse square root of n1 squared minus n2 squared by n0, or sine inverse numerical aperture by n0, and you substitute for numerical aperture 1219 and n0 is 1.4. So sine inverse 0.1219 divided by 1.4 and you will get 5 degrees. So 5 degree is the acceptance angle of the fiber. Another problem. The refractive index of the core is 1.48 and that of the cladding is 1.475. Light enters the fiber from air and you are asked to find the acceptance angle and numerical aperture. So given n1, that is the refractive index of the core is 1.48, refractive index of the cladding n2 is 1.475, and light enters the core from air, that is n0 is equal to 1 for air. You can find the acceptance angle. Phi is equal to sine inverse square root of n1 squared minus n2 squared by n0, and you will get a value of 7 degree, and numerical aperture is given by n0 sine phi is equal to sine 7 degree is equal to 0.1219.